Good morning, Algebra 1. I apologize, I'm not feeling well this morning, so I decided to stay home. What I made for you though is a video that goes over the 3-2 notes. So if you don't already have it out, please get out your Chapter 3 note packet from yesterday and turn to page 4. Okay, what we're going to talk about today is something called slope. In previous years, you may have learned it as the rate of change. The rate of change is going to be a ratio that describes, on average, how much one quantity changes with respect to a change in another quantity. Typically, this means there are labels involved, and we think of it in three ways. The first is we think of it as change in y over change in x. Sometimes you'll see that written as delta y over delta x. Delta is just a Greek letter, and it means change. You sometimes maybe heard of rate of change or even slope as rise over run. Typically, this is when you're looking at a graph, you can visually see the rise and the run. The third is that you might think of it as the change in dependent over the change in independent. And this goes back to, again, when we talked in chapter 1, we had talked about how the y values we talk are our dependent values, the x are independent values. So when you're saying change in the dependent over change in the independent, that's just saying, again, the change in your y's divided by the change in your x. So then it says, how does this relate to linear equations or linear functions? And so what we're going to say is that in a linear function, what should happen is that the rate of change should stay constant. So when it says here, how does this relate to linear equations? It's really linear functions there. In a linear function, the rate of change is constant, which means that it's going to stay the same. Okay. So now it says, if the rate of change remains constant throughout the whole graph, table, or list of ordered pairs, we can conclude that the equation is linear. So if your rate of change, if your change in x over, or change in y over change in x, if that stays the same throughout any 2 points on the graph, we would call that linear when it stays the same. When talking about linear equations, we refer to this as slope. So if you have a constant rate of change, which means you have a linear function, what we talk about, what we call that rate of change, is going to be called a slope. Okay? So here's a little box that summarizes slope. The definition says that the slope of a non-vertical just means not straight up and down. If you are getting a line that's straight up and down, it's not actually a function, so it doesn't relate to a linear function here because it's not considered a function. So if it's non-vertical, the slope is found by taking the ratio of the change in the y-coordinates to the change in the x-coordinates as you move from one point to another. The slope tells us how steep a line is. Okay, that's the general idea. It tells you how steep the line is. Okay, so if we keep going here, it says there are 3 check marks here. This is kind of where I'm going to summarize the 3 different ways we think of slope. So the first is that we think of it as rise over run. And again, we already talked about this with the rate of change. What it is if you were to draw a little graph like this, maybe do 3 marks in all directions. We put a point up at 3 and we're going to put a point down at -3, 1. If you connect those into a line and we want to find our slope, well, we're going up and to the right. So as we go up, we go 1, 2, 3, 4. We went up 4. So that's a distance, a rise distance of 4. Then I went right, 1, 2, 3. And so my run distance is a 3. That means that my slope, let's see, my slope, which is represented by m, let me put that right here, m is going to be my rise, which was the +4, divided by my run, which was +3. We don't need those pluses there. You can just write it as 4/3. Okay. One thing to keep in mind here is that up and right, if you're going up or if you're going right, that's going to be positive. If you're going down or left, it's going to be negative. So in that example there, we happened to go up and right, so they were both positive. But if you wanted to go the other direction, say we started up at this point and we went 1, 2, 3, 4, we could have said that we went down 4 and 1, 2, 3, 3 left. Your slope still would have been -4, -3. Two negatives would make that positive. So you would still get that 4/3 there. So keep that in mind as well, that you can always do that. Okay, the second one is something called the slope formula. And again, m represents our slope. So we're going to say if you're given 2 points, so 2 ordered pairs, how you can find your slope is you can say y2 minus y1 over x2 minus x1. Okay, so y2 minus y1 divided by x2 minus x1. So x1, y1 is one ordered pair. x2, y2 would be the other ordered pair. So if I gave you 2 ordered pairs, say -5, -8, and then I gave you an ordered pair of 0, 4, what we would want to call one of these, it really doesn't matter what. If this is x1, y1, this is going to be x2, y2. And so if I'm going to use that slope formula, I put the y's together. y2 was 4 minus y1, which was -8. x2 was 0 minus x1, which was -5. What you get here and what you want to watch for is that negative, that first negative, is just part of the formula. If you look up here, we're always subtracting the x values, subtracting the y values. So this first negative, that's just part of the formula. You can't use that as the negative on the ordered pair. So that's why you'll see over here that we have a negative, negative. Your last steps is that you're just going to want to simplify these. So 4 minus -8, that's really like you're adding them. You're getting a 12. Over here, you're getting a 5. So your slope becomes 12/5. And usually we check and see if it can be reduced. In this case, we know that that cannot reduce. Okay, so visually you can find the slope using rise over run. You can use the slope formula if you're given 2 points, or if you find 2 points on the line you want to use. The last thing is just using something that I call change in y over change in x. And what it is that I take 2 ordered pairs. Say I take that same ordered pair grouping that I had in the last example. So -5, -8, and I take 0, 4. What I'm going to do is kind of draw an arrow. So I'm going to think to go from -8 to 4. This is my change in y. How is it changing? Well, to go from a -8 to a +4, I have to add a 12. So -8 plus 12 gives me 4. That's my change in y. To go from -5 to 0, that's my change in x. So to go from -5 to 0, I would have had to add 5. So when I go to write out my change in y over change in x, I've already found those. Change in y was 12, change in x was 5. And that's how I get my 12/5 as my slope there. Okay. So again, I like to just kind of draw arrows sometimes, not always put it in the slope formula, but you need to find what works for you. Any of these methods are great. The rise over run, yes, it takes some time to graph it, but if you have the graph, it works really great. Okay. So those are sort of our three methods. If you go on to the next page, we're going to summarize the four types of slope that we deal with linear functions. So in this first column, what we're going to be talking about is the positive slope. And so on this graph, on this grid, kind of however you want to draw a line so that it's sloping upwards, it has a positive slope. Okay. If you look at how it is described for a positive slope, it says that function values are increasing over the entire domain. In other words, y values are going to increase as your x values increase. So as your x increases, your y increases. We can see that as we go right, as our x values get larger, our graph is getting higher. So x values get larger, y values get larger. Okay, what is going to happen is that we describe that as it's rising, so it rises from left to right. So that's positive slope. Your x are increasing, your y are x are increasing, y's are increasing. Your negative slope, this one is already like labeled at the top for us, but we are still going to draw in a couple things. So create a negative slope. That means that as you go right, your line looks like it's falling. What happens with the negative slope is that your function values, so function values which are your y values are going to decrease as the x values increase. And so when you look at that graph, as we go right, so as our x values get larger, you can see that this arrow, this line is going to keep going down. So as our x values get larger, our y values get smaller. Okay? And so what this looks like on the graph is that you're falling from left to right. Okay, the next one we have is something called a zero slope. Sometimes you come in thinking of something called a no slope. I do not use no slope. I use a zero slope and an undefined slope so that we can keep them separate. So a zero slope is going to be a straight line left to right. What it is that if you get 0 divided by a number, that's going to give you a zero slope. What happens here is that your y values, your function values, are going to be constant over the entire domain. So as our x values increase, our y value stays the same, essentially. It's going to look like a horizontal line. Again, that's left to right. The last one is what we call our undefined slope. And so this type of slope occurs when you have a non-function linear equation, really. So it's linear, but it's not a function because it fails that vertical line test. How you get it is you take a number divided by 0. So if you ever have something divided by 0, that's how you get your undefined slope. When you look at what it says, the relation is not a function because you only have one domain value, but you have an infinite number of ranges. So that's like saying one person has infinitely many birthdays. Domain includes only one value, so it's not a function. What this looks like is it's a vertical line. So vertical is straight up and down. We have just a couple more examples I want to go through here. Thanks for hanging with me. If you are missing some of this, the video is on Schoology for all of you guys to access. Go back and slow it down if you need to. I know sometimes I can start going really fast when I make these videos. Do your best. You got this. Okay, so now it says example 1. Find the slope of the line that passes through each pair of points. Simplify the slope if the fraction can be reduced. Do not leave your slope over 1, and do not leave 2 negatives in your slope. If a slope simplifies to 0 or undefined, make sure you specify that. So remember, just if you still need this, y2 minus y1 over x2 minus x1. I'm going to use kind of a combination of the slope formula and my change in x over change in y, where I just draw the arrows. You can go ahead and start working on these on your own. If you want to kind of just follow along up here, you can do that. So the first one, if I do slope formula, first figure out what you want x1, y1, x2, y2 to be. We're going to be taking y2 minus y1, 0 minus 5, over negative 2 minus 1. 0 minus 5 gets us negative 5. Negative 2 minus 1 gives us negative 3. Well, if you have two negatives that are divided by each other, it becomes a positive. So your slope is 5/3. Okay. The next one here. This one I'm going to use my change in y over change in x sort of thing. Okay. Let's see if I can move this. And so what I'm going to do is first find my change in y. My change in y is going from that 3 to the 11. So how do I go from 3 to 11? I'm going to add 8. To go from 4 to negative 1, that's my change in x. So if I go to 4 to negative 1, that'd be changing by a negative 5. So if my slope is found by taking change in y divided by change in x, that's like 8 divided by negative 5. That would be your answer. Or you could write it as negative 8/5, like that. Either one is going to work. For letter C, I'm going to go back to my slope formula. So I take y2 minus y1 over x2 minus x1. If I'm using those points, I might want to say 2 minus 2 over 7 minus negative 3. 2 minus 2 is 0. 7 minus negative 3, that's like saying a 10. So if you have 0 divided by 10, that simplifies to just a 0 slope. And you want to write it as 0, not 0 over 10. We want it as simplified as it can go. Okay, letter D, we have the ordered pairs negative 3, 4, and 2, negative 3. I'll use my slope formula again. So y2 and y1, I'm going to be taking negative 3 minus 4. x2, x1, I'm going to take 2 minus negative 3. Negative 3 minus 4 is negative 7. 2 minus negative 3 is 5. That means my slope is negative 7/5, or 7 divided by negative 5. It shouldn't matter which one you write. Either way works. Okay. Letter E, I'm going to go back and do my change in y and change in x. One thing to keep in mind here, you will notice that I go from the first point to the second point with my arrows. You want to stay consistent there. So if you start with the first ordered pair to the second, you want to continue that with both x and y. So from negative 1 to a negative 1, I changed by 0. To go from a negative 3 to a 2, I changed by 5. So if my slope is change in y over change in x, my change in y was 0, my change in x was 5, my slope ends up being just a 0. And the last one here. So this last one is that I'm going to take 3 to 7. So to go from 3 to 7, I added 4. To go from 6 to 6, I changed by 0. If I take change in y over change in x, I'm taking 4 divided by 0. Well, 4 divided by 0, if you put it in your calculator, it's going to give you an error. So what we call that is undefined. Okay. Okay, so if you have any questions, hopefully you can kind of ask the people around you as you get into your homework assignment. Hopefully you'll get some more practice. As I said, find the method that works for you. Some people really like slope formula because it always works. There's not as much that you can end up missing there. But some people like just drawing the arrows because they think it maybe goes faster. Okay. So turn to the next page. This is our last section, so hang in there. We have about maybe 10 minutes left. So it says example 2, determine if each function is linear. Write yes or no and explain. So how can we tell? If you have like a table like this, or if you have some ordered pairs, how can you tell if it's linear? And what this answer is that the rate of change or slope between any 2 points is the same. And so what I kind of like to do is just go x by x, y by y. So if we look at example A right here, to go from 4 to 2, figure out what you're doing. You're subtracting 2. To go from 2 to 0, you're subtracting 2. To go from 0 to negative 2, you're subtracting 2. And to go from negative 2 to negative 4, you're subtracting 2. It is the same throughout the whole table. Go to your y's. Negative 1 to 1, we're adding 2. 1 to 3, we're adding 2. 3 to 5, we're adding 2. 5 to 7, we're adding 2. So this one we're going to say, yes, it is linear. And instead of like explaining a lot, we're just going to put our slope is going to be 2 over negative 2, which if you simplify that, 2 divided by negative 2 gets you a slope of negative 1. So the change was the same between any 2 points here. And so we can say that it is linear. If you move on to letter B, and I'm going to go through that same process. So to go from negative 7 to negative 5, I'm adding 2. To go from negative 5 to negative 3, I'm adding 2. To go from negative 3 to negative 1, I'm adding 2. To go from negative 1 to 0, I add 1. Down here with the y's, 11 to 14, I'm adding 3. 14 to 17, I'm adding 3. 17 to 20, I'm adding 3. 20 to 23, I'm adding 3. When I look at this area right here, when the top part goes by plus 1, the bottom part goes by plus 3, this is what makes this not linear. Because you have that one piece that kind of throws it off. Okay, letter C. We're going to go through the same thing. If we're going, again, negative 0.2 to 0, we would have added 0.2 or 2 tenths to go from 0 to 2 tenths. We added 2 tenths to go from 2 tenths to 4 tenths. we added 2/10. To go from 4/10 to 6/10, we added 0.2. Down here, to go from 7/10 to 4/10, we subtracted 3/10. To go from 4/10 to 1/10, we subtracted 3/10. To go from 1/10 to 3/10, we added 2/10. And to go from 3/10 to 6/10, we added 3/10. So here you have a couple different ones that throw it off. This one and this change, because we go plus 0.2 plus 0.3, and the top didn't change. The top stayed consistent, so if it was linear, the bottom should have stayed consistent as well. So this one is not linear. Okay, our last one here. Okay, go by the x's. We're going from 1/2. Remember, this is just like a 1.5. This would be a 2.5. This would be a 3.5. This would be a 4.5. So, and then this is a 0.5. So if it helps you to put it as a decimal to find this out, you can sure do that. Okay. So to go from 1/2 to 1.5, we added 1. 1.5 to 2.5, we added 1. 2.5 to 3.5, we added 1. 3.5 to 4.5, we added 1. If you go and look down here, 1/2 to 1, 1/2 plus 1/2 gives us 1. This again is 1.5, 2, 2.5. So to go from 1 to 1.5, we added a half. To go from 1.5 to 2, we added a half. To go from 2 to 2.5, we added a half. So this one, our slope is going to be 1/2 divided by 1. 1/2 divided by 1 gives us just a slope of 1/2 there. Okay. Okay, here's our very last question. It says slope tells us the steepness of a line. So what line would be steeper? So I'm going to quick graph these. -2, -2 is right here. 0, 2 is up here. If you're going to connect those, and we want to find our slope, draw sort of this box. To go from one to the other, I go up 1, 2, 3, 4, and I go right 2. So the slope of this line is 4/2, or just a 2. If I go over here, 2, 1, and 0, 5, it's slightly different. It's going downwards, so it's a negative slope this time. If we're trying to figure out the slope, go from one point to the other. So if I start here, I go up 1, 2, 3, 4, and I go left 1, 2. And so my slope is 4 divided by -2, which is just a -2. So when it says which one is steeper, they are both the same steepness. One is just positive, one is negative. Okay. Okay, so page 7.